A very good morning to you, and you're very welcome to today's Signpost webinar. I hope you're keeping safe and well wherever you're joining us from today. My name is Mark Gibson, and I'm manager of the Teagasc ConnectEd programme. So today we're going to be talking about proactively improving human and environmental health through good science, particularly in the context of reaching carbon neutrality within the agri-food system. And I'm delighted to be joined by Dr. John Gilliland, who is Director of Agriculture and Sustainability at Devenish. John, you're very welcome to the webinar today.
Thank you very much, Mark.
And we're also joined by Pat Murphy, who is Programme Manager of the Teagasc Environment Programme. Good morning to you, Pat.
Good morning. How are you?
Great. So, John, you're very welcome. You're talking to us today from Belfast, I believe.
I am just north of Belfast, looking over a beautiful day, the Irish Sea. I'm very privileged to have a great view here at the moment.
Great. So, John, before we start, could you just give us a little flavour of the work that you're doing with Devenish? I know you're going to go into it in detail, but give us some broad outline of the work that you're doing.
Well, Devenish Nutrition is a livestock nutrition innovation company. We design solutions as such. And for many years, for the last 25 years, we have been focusing on precision nutrition. But we saw that our customers' businesses, actually, we needed to give them more solutions beyond just the animal. And so in 2013, we invested and we bought a farm of land. And we said, actually, can we look at a whole system approach of farming and look at the animal, but look at the environment that the animal sits within? And really, I was privileged. I joined Devenish in 2013 to lead this piece of work. And we've been on a journey at the Devenish Lands of Douth in County Meath. And hopefully today I will share some of that journey, and people will get a feel for our journey and why we believe passionately about our strategy that there is only one health, and it starts at the soil. It goes through all the way to the sward, the animals, right through then to the nutrition of the food into human health. And so the solutions we bring forward now are along the One Health agenda.
Great. Well, John, I'm really looking forward to your presentation. So if I could ask you to share your screen with us. And a reminder to everybody, if you have questions that you'd like us to put to John, you can send them through to us using the Q&A tab at the bottom of your screen. And today's session is being recorded and will be available afterwards. The presentation and the recording of the session will be available on our YouTube channel. So, John, I'm going to hand over to you. We can see your screen perfectly there now. So look forward to talking to you after the presentation.
Thank you very much, Mark. And can I thank, at the start, the outset, can I thank Teagasc? It's a privilege to be asked to come and engage with such a grouping of followers to the ConnectEd programme of Teagasc. And I've watched with interest its development. So congratulations to you and the team. As I say, what I want to do today in the next 30 minutes is just share with you a bit of our journey, and really for us, how using good science can proactively improve human and environmental health. So all being well, this will work. I've got a next slide, so hopefully you have a next slide there as well. I just want to take 2 seconds just to explain my own background. I, first and foremost, am a farmer. Sadly, I didn't go through the Teagasc education system. I went through the Scottish education system, and was a award-winning farmer and innovator in my own right from my farm in Derry. But I also, at a young age, got involved in agricultural politics and became the other youngest ever president of the Ulster Farmers Union, just in time for the foot and mouth crisis back in 2001. And since then, after I retired and had done my bit as president, I've done a lot of work as a policy advisor locally, nationally and internationally. I currently sit on the European Commission's Mission Board Assembly for Soil Health and Food. I also chair Northern Ireland's expert working group on sustainable land management and on ammonia. But for a period of time, for 7 years, I chaired the think tank on climate change for the UK. I was a commissioner, vice chair of the UK's Sustainable Development Commission, and a director of SRUC. And unusually too, I also was a regulator for a period of time. For 5 years, I was an energy regulator in Northern Ireland and helped put the power stations in Northern Ireland into the European Emissions Trading Scheme. So certainly the issue of emissions and how we get industries to change has been in part of my work. So moving on, I want to just articulate the sort of the Devenish vision here. And really for us, it is to inform and deliver more nutritionally dense and diverse food with an independently verified lower environmental footprint. And really what came to the core was a piece of work that was published in 2010. And I'm just using this example about milk. There are many drinks that we as humans can have. And here on the left-hand side, you can see all the different drinks: a soft drink, orange juice, beer, red wine, mineral water, soy drink, oat drink. But what people don't realize is they have different nutritional benefits to humans, what we call nutritional density. They also have considerably different greenhouse gas emissions per litre produced. And really what Smedman did in 2010 is he actually combined, he said, listen, we need to think about not only reducing the environmental footprint of the food we produce, but actually recognizing the nutritional value it has to humans. And when you actually create this new index that they did in 2010, the nutrient density per climate impact, what you saw that although milk was had one of the highest greenhouse gas emissions, on a nutrient density climate impact index, it came out far better on the quantity of nutrients that they provide humans with the minimal climate impact. And that really focused our mind. We felt we needed to change our product and help the industry go in this direction. So what did that mean to us? Well, for us, we felt that if you're going to go on this journey, you actually need to look at the complete food system, where it starts in the soil, what the impact of good soil health has on the sward, then on the animals, on the meat quality, the nutrient density of that quality, and its impact on human health. So our strategy, One Health from Soil to Society, and in our case, we're looking to optimize the nutrition at every stage going through that. So having come up with the strategy, we said, well, what are the outworkings of that? And so in 2013, Devenish bought a 105-hectare farm called the Lands of Douth between Slane and Drogheda. And it's a grassland with large wooded areas and lovely landscape, but sadly tired. The previous owner for 40 years had taken from it and given nothing to it. And so really what we've done over that journey from 2013 to today is we've developed a collection of programs there, from delivering soil improvement, not only improving our fertility, but improving our soil health, from measuring our carbon sequestration, not only below the surface, but above the surface in our trees and hedges, to looking at our impact on water quality. Where does any excess soil or excess phosphate run off our land and into water courses? So actually, if we're going to do a landscape intervention, where exactly do we put it and what size does it need to be? Biodiversity is a huge issue, and we have a lot to do in Ireland to improve it. We have a particular challenge in Douth, as we have one of the last lowland herds of wild red deer. And we want to, they are Ireland's top mammal, and we want to see a healthy, sustainable herd of wild red deer in the Boyne Valley. But we also want to see healthy trees, and we want to maximize our carbon sequestration. So actually trying to find where is the optimum between managing our top mammal, our top wild mammal, and managing our carbon sequestration of trees. Really quite a challenge. And if that wasn't enough, the whole of the site is within the UNESCO World Heritage Site, Brún na Bóinne. And over the last 7 years with our partners in UCD, we have uncovered 6,000 years of continuous farming and food evolution and how it impacted on the landscape. And it has its own difficulties, but it has also, we've found many synergies between what we need to do in the name of cultural heritage, and what we need to do in the name of sustainable farming. And for recognition of the journey we've been on, we were privileged 2 years ago when we were approached by Gilliland University Research to be one of their first 3 farmers to join their new global network of lighthouse farms. A network of 11 farms, 6 in Europe, 5 outside Europe, of farms that have gone beyond best practice, where we share on an international basis our journey, and we learn from other international exemplars. So our key focus is we wanted to see, could we develop a farming system solution that would accelerate our journey to net zero? And could we do it by 2025? Many people says we're mad, couldn't be done. Well, we wanted to have a go at it, because it's not until you have a go at it do you actually find where some of the barriers are, where some of the knowledge gaps are, and actually find the solutions. So for us to do that, we wanted to focus on credible, verifiable measurement of improved farming practices. And we want to do it in a way that annually we could calculate our gross greenhouse gas emission, our gross carbon sequestration. And by working those 2 out, we can net them together to give us our net annual greenhouse gas position for the whole farm business, not just for the enterprise, but for the whole business. Because as a land manager and a farmer, I don't just manage the livestock there. We manage the trees, the hedges, the soils. And so we're looking at the totality of all the tools in the toolbox. And we designed then around that a communication tool that we call a whole farm annual carbon balance sheet. And that allows us to inform our journey of progress, and it allows us to communicate our journey to our peers and the wider community out there. If you're going on this journey and you want to be transparent and you want to be robust in how you do this, you actually need to go out and create robust baselines right at the start. So in 2014, we commissioned 3 totally different GPS-based surveys. One was precision soil sampling analysis on 2 hectare blocks, 25 cores and 2 hectare blocks, through what we call virtual land parcels. We also did an aerial LiDAR survey, and we also did a geophysics survey. The last 2 predominantly to help us with where our archaeology was, because we need to be very careful. We cannot be accused of destroying our cultural heritage here. And what you can see from our soil baselines is we had a brown earth soil, a mineral brown earth soil. Our pH was awful. Potash was just borderline. Phosphate, most of the phosphate was very poor, with unusual hotspots, which subsequently found out was the legacy of phosphate from the medieval ages. And this is heritage phosphate, something I'd never heard of before. The second thing we did, as I said, we commissioned a aerial LiDAR survey. And I publicly want to thank Teagasc, and particularly Stuart Green and Teagasc, for the help he gave us in this. Because in 2014, early 2014, the EPA published a document of hedgerows in the Irish landscape. And it really was a piece of work that Teagasc and Stuart had done about how you use LiDAR to measure the amount of carbon in a hedge. And when this was published, we went to Teagasc and they very kindly engaged. And at that stage, we had our LiDAR data for the whole of the farm. And it was agreed then that together we would analyze, we'd be the first farm in the world to analyze all our above ground carbon. And courtesy of Stuart, the table that I'm showing you here in the orangey brown gives you the summary of that. Is that in our biomass density in tons of carbon per hectare in our woodlands, with 83 tons of carbon per hectare, in our hedges, 127. And it comes as no surprise that hedges would be more carbon dense. You can walk through a woodland. It's really hard to walk through a hedge. And from that, we could get an accurate prediction of what our annual sequestration rate is going to be. The next thing we did is, having done our GPS soil sampling analysis, that was done to 10 centimeters to do our pH, our P and our K. But if you actually want to go and measure your soil carbon, courtesy of the International Panel on Climate Change, there are guidelines around that. And we, courtesy of support from Gary Lanigan and Teagasc, we sampled 30 centimeters, and we did 88 soil pits representative across, geographically spread across our landscape, again marked with GPS. And our reason being is every 5 years we want to come back to the same area, give or take a meter, because that's the inaccuracy in a handheld GPS, and actually see, can we measure change? So every 5 years we'll come back to do this, and can we measure either an improvement or a reduction in our soil carbon? What we weren't expecting to see is actually when we did this, our average soil carbon in Douth was 2.1%, which blew our mind, because what we did know, it was a brown earth mineral soil. It had not been ploughed for 40 years, and some of it had never been ploughed before. It's a heritage farm. And we did expect our soil carbon to be in the order of 4 to 5%, because it had been under long-term grass, and certainly that, if you listen to the IPCC's subcommittee on carbon sequestration, they say soils under long-term grass plateau in soil carbon. Well, we didn't see any plateauing here, and it really begged the questions. One of the research questions we've been tackling is why the disparity in soil carbon levels on Douth vis-a-vis other farms of brown earth mineral soils. So once we did all that, we were able to get a gross emission of greenhouse gases. We were able to get a gross sequestration rate of carbon, and that allowed us to create a net farm position. So, okay, let me explain what you're looking at here. This bar chart. Up the left-hand side, you've got the total greenhouse gas emissions for Douth on an annual basis. Along the x-axis, you've got a sensitivity analysis done at different livestock stocking densities. So on the left-hand side, you can see 1 livestock unit per hectare. On the right-hand side, you can see 2.5 livestock units per hectare. Currently at Douth, our target is 2 livestock units because we're an underogated farm. And what we're saying is that 2 livestock units per hectare, we can have 182 cow-calf equivalents, whose gross emission, so our gross emission of farm is 1,161 tonnes on an annual basis. But we know from our work in measuring our carbon and using annual carbon sequestration factors from the best available knowledge today, we're sequestering 665 tonnes. So what I'm saying is our gross emissions are 1,161. Our gross sequestration is 665 tonnes. And so our net position is 496 tonnes for the farm on an annual basis, which for Douth, we are currently displacing 56% of all our greenhouse gas emissions from our cows and calves because of our soils, our trees, and our hedges. So that is the difference between your gross position and your net position. And I was determined to get there because our industry is reported on gross emissions per enterprise or per livestock unit. And it does not give the true reflection of what our net position is. And I'm really delighted that the European Commission, in their publication last week, looking at the greenhouse gas targets for 2030, are now looking to bring together the national inventory of agriculture and what they call land use change, to recognize that actually we need to start measuring agriculture on its net position and not on its gross position. So the challenge we've set ourselves is how do we get net zero or carbon neutral by 2025? And we have 2 options. We can, from this sensitivity analysis, reduce our stocking rate to 1.25 livestock units per hectare. And at that, we would be carbon neutral today. But the challenge of that is we still have a global community who wants to eat livestock products. So if we destock, all that does is it chases those consumers who don't want to change their consumption behavior to places like South America, where you only accelerate deforestation. So our opinion is, can we stay at 2 livestock units per hectare, but can we do things on the farm to mitigate greenhouse gases, to accelerate carbon sequestration so that we can get to net zero at 2 livestock units per hectare? So I also want to show some of the things that we've been doing. the very first thing we've been doing is correcting our soil pH, because what people don't realize, in a mineral soil, your carbon is biological. It is not permanent. It is in a state of flux. And that flux is totally dependent on pH. So if you've got an optimal soil of 6.5 pH, your soil biology is churning over at its optimal rate. As you drop the pH, the soil biology, the speed that it turns over slows down. And in fact, at some stage, it stops and it starts to respire. And we suspect that is why Dow's soil carbon was so low, is in 2014, our average pH was 5.5. So what we've been doing is we've been measuring and managing every 2 years. So you can see 2014, 2016, 2018, 2020. And what we've been doing is we've been putting a little bit of lime on every 2 years and measuring the consequences. And you can see over that period of time, we've transformed soil pH, and only in 6 years. And alongside that, we've seen extraordinary increases in grass production and therefore grass utilization, driving profits, just by getting our pH correct. And we've also, because it's digital, the last 2 applications, we've been able to use a variable rate lime spreader, where we've put in the data and they spread the lime where we need it and have not spread it where it's not needed. So really trying to digitalize what we do. The second thing is we then wanted to look at the swards, because we had this stunning heritage sward, not overly productive. It was very diverse, 26, 27 different species. But what we wanted to do is we wanted to see, could by introducing herbs and legumes, could we dramatically change our production and our environmental footprint? So we were very fortunate. We, along with our partners in UCD and Wageningen University Research, we secured an EU Marie Curie Award to employ 5 PhD students and to create a platform of 36 hectares of 4 different sward types. One of those was our old permanent pasture. One is straight ryegrass. One is a 6-way mix of 2 grasses, 2 herbs, 2 legumes, and one is a 12-way mix of 3 grasses, 4 legumes, and 5 herbs. And we've now finished a year on that. And just to give you an understanding, and we're co-grazing with beef and sheep, and just to give you some kind of feeling of the results we've had in the first year. Now, bear in mind, this is only 1 year. So, I urge caution, next year could be completely different. But you can see in kilos of dry matter per hectare, and this was by the end of September, you can see there, the red bar is the perennial ryegrass, and with 170 kilos of nitrogen per hectare, we're just getting over 10 tons of dry matter per hectare. Our permanent pasture, as recommended by the Green Book in Teagasc, we only had 135 units there, and we're getting just under 8 tons of dry matter per hectare. But interestingly, where the 6 species and the 12 species multi-species swards with only 70 kilos per hectare of nitrogen, we're getting up over 12 to 13 tons of dry matter per hectare, which is really quite extraordinary that you drop your nitrogen levels by 60% and you increase your output. We didn't see that scale coming through. And actually, if you look at the right-hand side and you look at herbage growth rates over the calendar, you can see, and the same colors follow through. So the multi-species are yellow and green. Blue is the old permanent pasture. You can see the bit in the box is actually that drought we had, so the March, April, May. And what we actually saw is that the multi-species put down these huge, big, deep roots, were able to bring water and minerals up from down low, and they rumped away. And they also were synergistic to the grass that was in their own species mix. So the ryegrass in 6 and 12 species mix did very well, even through the drought. But the straight perennial ryegrass really suffered because it didn't have those deep roots that the multi-species swards have. I have to say the other thing that was quite extraordinary is we've measured change in worm populations. And in 1 year, we've had a 3-fold increase in the amount of earthworms in our multi-species swards. The other areas we're looking at accelerating our carbon sequestration. We've done our first initial experiment with silvopasture, putting trees and animals together. We hope to do our next big tranche this coming winter as such. We've been working with Jim McAdam of AFBI, and they have some astonishing data from Loch Gall and County Armagh, where they have been looking at silvopasture with ash trees, perennial ryegrass and cypress spruce, looking at different carbon sequestrations. And you can see there that silvopasture is at least doubling, if not trebling, the carbon sequestration, while at the same time really driving biodiversity, which they've been measuring. I think for me, the most interesting bit has also been the benefit to the trafficability of soil. Because as livestock farmers, at the end of the day, the key metric that shows our profitability is not the amount of herbage we produce, but it's the amount of herbage we utilize and turn it into sellable milk and meat. And what we've found with the silvopasture is that you can extend the soil trafficability by up to 17 weeks a year. And what we find in many Irish farms is we can grow plenty of dry matter. Our problem is our ground conditions are too wet to carry our animals or to carry our vehicles to utilize that. And so we think there's a real production benefit of putting trees and animals together in part of our grazing platform. I don't want to ignore the animal side, and it'd be fair to say that we've also had some stunning live weight gains with the multi-species swards, which has lowered our greenhouse gas footprint per kilo of beef and lamb. But the other area we're also looking at, and we've partnered up with our Australian colleagues, CSIRO, CSIRO, they're the Australian government, they're sort of the equivalent of Teagasc, except they also do human health as well. And this graphic that I'm showing you here, I've taken from their National Livestock Mitigation Programme. And it's basically a comparison of all the different solutions out there that can help drive mitigation of greenhouse gases from the animal. And it is everything from improving genetics, right through to vaccinations, to putting in biochar or charcoal, bioactives, or like garlic or citrus. NOP, that's DSM's new synthetic product, 3-NOP, a 35% reduction. And the one that's getting the most interest at the moment is the work with red seaweed or algae, and certainly looking at a 60 to 70% reduction in greenhouse gases. And we think that certainly these technologies have a real role in the toolbox of driving mitigation. I don't want to forget about the monogastric sector. Just one slide in here about monogastrics. We, for the last 15 years, have really been leading the world on precision nutrition, and particularly in monogastrics. And one of our key products is about displacing crude protein in the diet with refined amino acids. And where we've done that and done that successfully, these results are from trials we've done with AFBI in Hillsborough and have been validated by SRUC's and SAC's agri-calculator. We've seen a 5% improvement on growth rate. We've seen a 17 kilo per pig reduction of soya, which is really important at the moment. Retailers are really looking to get soya out of the diet or reduced in the diet. But if you feed less crude protein, the pig needs less water, 25% less water intake, with an ultimate 38% reduction in slurry volume, which is astonishing. From the environment point of view, the big win, and it's a huge issue in Northern and becoming an issue in the Republic of Ireland, is the reduction of ammonia, just short of a 50% reduction in ammonia emissions and a 16% reduction in greenhouse gases. So there are many things that we can do to actually improve our environmental performance. But in this journey, it is really important that we in the industry also understand what's going on out there. And our industry is constantly being measured, and they use metrics to measure us. And one of the things that we really have, tried to embrace is actually, are we using the right metrics to measure our industry? Because our job is not only to deliver on the environment. Our job is also to produce nutritious food to actually improve human health as well. And it's not either or, we have to do it simultaneously. And I've got this slide, it's a bit confusing, but bear with me a moment. What I'm trying to do on these three graphics that are there is give you an understanding of the perverseness. If you go and look at measuring greenhouse gas footprint per 100 kilos or 100 grams of a product. What happens is that actually fresh fruit and veg have the lowest carbon footprint. Okay, and that is currently what is happening. And that's why there is a great race to plant-based foods away from livestock production, okay? If you then say, okay, that delivers on the environmental good, but does nothing to deliver on more nutritious human food. So if you then look at greenhouse gas footprint per 100 calories, you get another perverse outcome, because actually, when you look at it per calories, the thing that comes out best are boiled sweets. And that's the last thing we want people to do, is run off and eat sweets. So really, another piece of work that was done back in 2015 by Devenish et al. Is actually saying, should we not be looking at a more intellectually rigorous metric? And the one that they have proposed is actually looking at the greenhouse gas footprint per nutrient density of the 15 key micronutrients that you and I need for healthy life. And when you do that, if you look up the y-axis this, you can see greenhouse gas emissions per 100 calories of food against then the quantity of that basket of 15 nutrients, essential nutrients in the nutrient density. And what you can see very quickly, the orange circles are what they call other foods. So they're plant-based foods. The blue circles are meat and dairy. And what you can see very quickly, the ones that have the lowest environmental footprint are down on the left-hand corner. And those are all your plant-based foods, and which is great. But there is a problem with that. And they don't on their own meet the criteria to give you that nutrient density and diversity of food you need for healthy life. And whatever way you look at it, you still need to bring in animal products in there. And when you then factor animal products in around their nutrient density per greenhouse gas footprint, then, they actually don't look as bad. So for us, what we want to do is say, is there a way that we could reduce the environmental footprint of animal products and actually make them more nutritionally dense? And so to do that, you have to actually understand that there is a real role of food, nutrition, and human health. And most people and our media peers haven't necessarily got this in their mind yet. And what we've done in this slide, and sorry, there's a lot of figures in here, but just bear with me a moment. This slide we have taken from the Lancet 2017. So it's a world-leading published journal. It is the data set that the Eat Lancet used to create the Eat Lancet report. But what it has done here, it has categorized human health, or human ill health or human deaths. So ill health is what we call disability adjusted life years, or DALYs, into nutritional excesses and nutritional deficiencies. And what you can actually see is that there are 3 to 4 times more ill health people because of deficiencies than excesses. And I would argue, when is the last time you've gone to a shop that it actually tells you on the label about the nutritional deficiencies of food? It does go to some extent to tell you the nutritional excesses. But when you look at that, you can see the real ones that cause ill health is we eat too much, diet high in calories, too much salt. And really interesting, going down to look at diet high in red meat, it's not even 5% of the total, yet it's the one that gets all the focus. If we go down to look at nutritional deficiencies, and Eat Lancet did raise this, we don't eat enough whole grains, we don't eat enough fruit, we don't eat enough nuts and seeds, we don't get enough iron. We don't eat enough vegetables. We don't eat enough marine omega-3 polyunsaturated fatty acids. Interestingly, diet low in iron, 35.8 million people involved are caught up with that, predominantly ladies or females, and young children. And of course, where is the main source of heme iron? It comes from red meat. And we don't see that linkage. So what we're trying to do is bring some transparency and make the connection between food, nutrition, and human health. For us in Devenish, we've tried to step into this space, and we already have some solutions out there. So just to give you an understanding of what we've done,
John, we have about 5 minutes left.
Okay. Thank you very much. We have used, at the moment, we know if you eat oily fish, you improve your omega-3 levels, you improve your mental well-being, your cognitive heart function. So our problem is we don't have enough sustainable fish. So really what we did is we took microalgae and we said, could we go from microalgae to animal feed, from animal feed into something that a lot of people eat, which is chicken and eggs, to actually produce an enriched product. We did that. We then, with the help of the Royal College of Surgeons in Ireland, did a full-blown human intervention trial to see actually, did we improve people's human health? And what we found over 6 months, we had a dramatic improvement of the people in omega-3 risk areas to people who were less risk because of the omega-3. So really, we have published that now. Professor Alice Stanton, who's our Director of Human Health and also from the Royal College of Surgeons, presented this at the American Heart Association in California and got the best international paper. This product has gone live, the chicken in Waitrose, the eggs in Marks and Spencer's. So really showing how you can do that. So really for us, we believe through this kind of work, we can deliver our vision, which is to take livestock products through precision nutrition, through land management. We can reduce their environmental footprint, but also through making sure that we give them the right nutrition, we can enhance their nutritional density. And we believe that's where we need to go as a livestock industry to improve human health and to improve environmental health simultaneously. So from Devenish point of view, right at the core are the 17 United Nations Sustainable Development Goals. I've just given 4 examples. We believe we are delivering against 11 of the 17 at the moment through enhancing cow welfare through our soil improvement program, improving human health with our omega-3 enriched chicken, stimulating pork production in Uganda with our partnership with Irish Aid, and improving environmental health through our sustainable agriculture and land management. I hope I've shared with you over the last 25, 30 minutes that actually we can deliver smart food solutions. But to do that, we need to use good science proactively. And by doing that, we can improve human and environmental health simultaneously. This journey, the transparency in this journey, the feedback back to the farmers, is we find this has empowered positive improvements in farm management practices. It brings credible transparency, real change, future profits, because the farming industry has to be profitable, but it absolutely mitigates risks. For us, our future solutions have to be on the One Health agenda from soil to society. Thank you very much for listening.
John, thank you very much for that inspirational presentation, and it's fantastic work that you're doing up in Louth. It's great to see that it's delivering results. I suppose one of the questions I have is the whole, how around the footprint versus absolute emissions in which we are measured against. The EPA has to report annually on the inventory that's sent back through the Commission and through to the IPPC. So where does what you're presenting here, the footprint approach at a nutrient density level, how does that marry with absolute emissions? And there is a time lag there that we would see. That maybe the science is a little bit ahead of policy here. How do we get to that point? Because I know there's all sorts of trade deals being done. There's meat product coming from these countries that would have that higher footprint when you look at the per calorie basis or per micronutrient basis. How does that all gel together? What sort of work needs to be done there to bring us to that point where this science is accepted as a way of a true measurement of the carbon footprint of farming?
So I believe that actually there is now more policy recognition in Brussels there than we in the industry actually understand. I think the farm to fork strategy that has been published actually sets the roadmap on how we're going to get there. I've been privileged over the last now 12 months to be part of the Soil Health and Food Mission Board Assembly with the Commission. and this has been fed in. We saw only last week the European Commission publishing their proposals for the 2030 greenhouse gas targets, where they're now looking to actually recognise farmers on net emissions, not gross emissions. So they're looking to amalgamate in the national inventory to which we have to report against. It's not only agriculture, but land use and land use change, and bringing them together so that you can create this on-farm balance, okay? Because, you know, when I was an energy regulator, when we put the power stations in Northern Ireland into the European Emissions Trading Scheme, some of the companies, and it was done on a company by company basis, some of the companies had both coal-fired power stations and wind turbines, okay? And actually they were allowed to net one against the other. They were, you know, and so their annual reduction trajectory was based on their net emission, not their gross emission, okay? And we're saying, actually, why should agriculture not be in the same position? In fact, I will argue even further, agriculture is the one sector in the economy that can do more than it has to do, because we've got biology on our side. We've got things like soils, trees, hedges that can all up their game. And we can lock up carbon for a period of time through these tools. So I think the challenge that is being discussed at a policy level is, how do we actually incentivize the land-based sectors, farming, woodland, forestry, to actually do more for society than they are currently doing. Understanding, and it's interesting, I don't know if anyone has seen the latest comments from Joe Biden in the last 4 days. Joe Biden has said very clearly that one of the secret weapons that he's going to bring forward in the United States in his term is actually sequestering carbon in soils. And so there is a bigger recognition. I think there is an onus on organizations like Teagasc and SRUC and Wageningen is, how do we measure that? And how do we bring visibility to that journey? So my point when I'm engaging with policymakers is, until you actually go and do it, you won't actually truly know. So, you know, Teagasc's initiative around the signpost farmers, we're going to go and do it, okay? We're going to go and measure it, you know. That to me is absolutely fundamental. What frustrates me is when I'm on a public stage and I'm bombarded and I don't have enough sound data. So the idea of DOUF was to create the data to which then we could articulate from and give people confidence, open it up to lay people that they can come and see it for themselves and watch our journey and see the science. It is very refreshing when you take a spade and you take a sod from our perennial ryegrass and take a sod from the multi-species sward just over the fence, and you just see physically with your eyes the scale of root difference, the understanding of the carbon difference, and the proliferation of worms. You know, wow. And we have found that really helpful, and we have had many policymakers, not only from Ireland, but from the European Commission through, and they understand our journey. I think there is a tide mark that is changing, that is recognizing that gross emissions from our industry, as is currently required by IPCC in the national inventory, is a very crude tool. And it does nothing to improve the other agenda, which is human health. And COVID, if we've learned anything from COVID, is actually people who have good health through good nutrition are more resilient. It doesn't stop them from getting COVID, but it mitigates the severity of the symptoms.
Thanks, John. We've had lots of interesting questions coming through here, John. So I'm going to hand over to Pat to maybe to go through some of those, and we'll keep it moving swiftly.
There's the kind of themes from your talk. I suppose a number of questions in relation to the mixed species sward. And the first one is how long do you expect your mixed species sward to persist for, or are you anticipating issues there?
Yes, we are. All the evidence says that mixed species swards are not as resilient as perennial ryegrass. So we need to understand that. We have changed our grazing regime. In our mixed swards, we don't actually start grazing until there is greater cover. And we will not graze them as tight as we would with perennial ryegrass, because their growing points are higher in the plant, okay? So you want to keep them there for as long as possible. But we expect that probably every 5 years we're going to top up the diversity of our multi-species swards. And so we need to program that in, okay? But from our point of view, if we're getting a 60 to 70% reduction of nitrogen, we're getting an increased output in dry matter and live weight gain. That pays for a little bit of extra cost in seeding. But it also means that we can deliver on our environmental footprint. We can hold our head up high and give society the data that our super tanker is turning around and it is doing something that they want. And we want as farmers, because I have a son, I have a grandson, I have a granddaughter. I would like them to farm too. And there's an onus of me that I'd make, try and leave my place in at least as good a quality as I inherited, and preferably better quality than I inherited it. And that is no different to farming families across this island of Ireland.
A quick follow-on question in relation to establishment method for and I suppose the ongoing maintenance method that will be used there.
So we have, within the trial block, we have a separate trial, which is metrics of about 80 different, it's got the 4 different sward types, but we've 2 different establishment techniques, and we're also looking at different applications of slurry to try and tease out, Pat, this question that you're asking about persistency. Because it is the millstone that overhangs the perception of multi-species swards. So for us, we have, in our case, and it was complicated because Dowth is a World Heritage Site. It is greatly frowned upon if we go and do a deep plough. So in Dowth, what we did is we actually burned ours off, we disked, and we direct drilled into the disc. In the smaller trial, we have we've ploughed, we've cultivated, and we've direct drilled, and we're looking at the establishment under each one of those different establishment regimes to try and put some data around that, Pat, so that we can make better informed decisions. And of course, it is soil type specific too, and we understand that. But at least what we're hoping to do is give some sound data so people can make educated, decisions.
Question here from Leon Coe. By applying lime and correcting soil fertility, did carbon sequestration in grassland increase? And if so, by how much? Or are you getting any sense of that, or is it too early?
So it's too early. So let's call a spade a spade. It takes, like a 5-year period to notice, detectable differences in carbon sequestration. And it's one of the challenges about bringing in carbon sequestration in soil is you can't detect it every year. What we have is anecdotal evidence, which is about root mass and worm population and whatever else. Now, those are all indicators that say our soils are going in the right direction. What we have done is we have created this very detailed baseline in 2017. We intend to go back and visit that baseline in 2022, 5 years later. In the 36 hectares of trials, we are, with our colleagues in Wageningen, we are trying to get early indicators to see, are we seeing an acceleration in soil sequestration in different sward compositions? Because we do expect, again from the published literature, is swards that have more diversity with longer roots can lay down more carbon. And so we are expecting that, but we want to see that in the data. And it's too early yet, Pat. But that is our expectation.
Okay. Question here. Do you believe an Irish grass-based dairy system, as stocked at 2 livestock units per hectare, which is what you were talking about, can be carbon neutral? Is that an end point to aim for?
Yes, I do. And I'm very clear now. But it is about doing 2 things simultaneously, Pat. It is about, first of all, how we do our best to look at mitigation and simultaneously do our best to accelerate carbon sequestration. So for me, in an Irish dairy farm, I see a grazing platform that will be somewhat different to what we have now. It will be a 3-way mix of perennial ryegrass on one part of it, because it makes, one of the weaknesses of multi-species swards is trying to get persistently good quality forage, winter say, multi-species swards and silvopasture. So you build a more resilient grazing platform So you're looking to optimize your biological system, and that will drive your carbon sequestration. I am also very impressed. I have had the privilege to go to Australia. I have seen the work that Saro have done on mitigating methane using products like Asparagopsis red seaweed. At 0.5%, they have seen a 90% reduction in methane. So I actually believe between improved genetics, improved feed nutrition, feed additives, improved carbon sequestration, you will accelerate our road to net zero. There will always be some people who will never get to net zero, but there will be others who can go beyond net zero. At the end of the day, what the nation has to do is to deliver net zero. And so people need to get in their mind, net zero is not that everybody gets to net zero. Net zero is the nation gets to net zero. And around that, we have a mechanism for the people who can do more carbon sequestration, encourage them to do it. For the people who will always have some unavoidable carbon that they cannot mitigate themselves, at least then there is a nation offset that is created within the nation, audited within the nation, and it's about Ireland putting its own house in order. So we need to understand, and that is no different to what we did when we put the power stations in, is that, you know, the renewables created the credits and the coal-fired power stations had to go and buy credits, you know, and that gave the incentive to accelerate people beyond what they're doing now and getting them beyond carbon neutral. Most people out there don't realize that farming can be, and there are farms already in Ireland, but they're not measured, that are already beyond net zero today.
John, there's some that would argue that the targets that have been set down for ammonia emissions are more challenging than those for greenhouse gas emissions. You know, what do you see there in terms of what sort of mitigation measures are you implementing at Dow's to address that? And do you see that we're going to achieve these emission ceilings that have been set out for the sector? Because we know that agriculture contributes to the vast majority of ammonia emissions in this country.
Mark, I think you've asked probably the most pertinent question. Okay, I believe we will deliver net carbon zero. I am not comfortable that we have all the tools in the toolbox about improving water quality or reducing ammonia emissions and the subsequent nitrogen deposition on priority habitats. I've had the privilege for the last 3 years to chair the expert working group on ammonia in Belfast. What most people south of the border are not aware, that if you want to expand your livestock business in Northern Ireland today, you will be absolutely frustrated by planning at the moment. It has more or less paralyzed any further modernization of the industry till we sort out ammonia. So ammonia is really difficult. So for us, there are 2 or 3 key things we do. And in fairness, Teagasc have done a lot of work on this too. So, you know, Teagasc and AFBI talk to each other. It is very helpful, along with Rothamsted in England and Centre of Ecology and Hydrology in Scotland. You know, there's a good body of research going in here. The first thing for us is, can we reduce crude protein in diets? Because rule of thumb, certainly in the monogastrics, and we're trying to see, does it work for ruminants, is for every point that you reduce crude protein in the diet, you reduce ammonia emissions by 10%. And that's one of our successes in pig nutrition, is we've reduced crude protein by 5 points, and we've had very nearly a 50% reduction in ammonia emissions. So that's the first thing. The second thing is, can we keep urine and feces separate? Because ammonia emissions only happens when urine and feces mix. So when a cow is grazing in a field, it very rarely defecates where it urinates. Okay? Which means that keeping cows out of grass is the most simplest way of actually reducing ammonia emissions. It is not until you bring them onto a concrete stand or a hard stand that the urine and feces mix, and that is where ammonia comes from. So that's why you've got some people looking at fancy slats and keeping yards clean to try and keep that ammonia down. And then the last key thing is, and how do we spread our slurry? And, you know, we have to sadly move away. The splash plate has served this industry for 40, 50 years very well, but its time has passed. And we need now to look at training shoes. And I mean, certainly with us, the huge expansion of training shoes on umbilical cords has, certainly in my area, just taken over. And I think we just have to embrace that. Our expert working group has recommended that we see the ban on the sale of new splash plates by 2022, and for the eventual phasing out by 2025 of splash plates. I know that's hard for us to absorb as an industry, but actually the problem with ammonia emissions, it creates nitrogen deposition and it falls within a 15 to 20 mile radius of your own home. And so it's just like if we impact on water quality, it impacts our local environment. We have no other choice. We have to get our head around this. So for me, the biggest simple solution is, can we reduce crude protein in diet, and can we keep animals outside for as long as possible? Can we build grazing platforms that are more resilient? And that's why I'm a fantastic fan of silvopasture, because it allows our soils to be trafficable for longer, and we can keep our animals out and reduce the ammonia emissions coming from our systems.
We're getting close on time. A few quick questions. Silviculture, what species are you using in your silviculture? What are the options?
Well, it's interesting, and I mean, at the end of the day, I don't claim to be the expert. I have been educated by the expert, and that's a gentleman, a very modest gentleman called Jim McAdam, who's now retired from AFBI, but led the research in Loughgall for 30 years. Jim chose ash 30 years ago, because 30 years ago there was no such thing as ash dieback, and there was a great market for good quality ash to go to create hurls. Okay, and he decided that the Irish culture of hurling would never allow there would never be a market for ash. And he's been very successful. What he didn't see was ash dieback coming along. What is interesting is actually the level of ash dieback in his silvopasture is insignificant to the level of the ash dieback in the hedgerows around them. Is that the animals have made a synergistic benefit to the trees. Because ash dieback is a fungus, it comes onto the leaf. When the leaf falls, it goes onto the soil. Next year, when the new leaves come out, the old leaves inoculate and the spores go up. So if you've got animals grazing around the trees, they eat those leaves. They greatly diminish the inoculant that overwinters. And so you don't stop the ash trees from getting ash dieback, but the ash dieback doesn't set in to October time. So you really, and so he has a system up there that his ash trees in the silvopasture are stunningly good. And all the ash trees around look awful. So now he's now looking at hybrid cherry. And he's also then, and I think the great thing about silvopasture is you decide what species suit the environment that you're in. I'm also interested about silvopasture is what species can we use to get cattle in quickly. So some people know I was Mr. Willow for a long time, and we're going to bring willow and hybrid cherry in, because we know certainly with some of the willow clones that we can get cows in within 2 years because they just grow so prolifically. We also know that they can be coppiced and pollarded well. So we can, every 5 or 6 years, we can manage them, take off a crop of biomass, and still optimize our grass production and therefore our livestock output. So I think there is massive room for further exploring the systems. And certainly in Douth, we have a couple of different mixtures. We've got some oats in there, we've got some alder in there, and that's also reflecting our heritage landscape. So we will be picking tree species for different spots depending on what we want out of it. But some of them will be quick growing because I want to get cattle in quickly. Some of them will be slower growing, and we'll plant them in a different way so we at least can get 4 or 5 years of grass, of forage herbage harvest off it. Because at the end of the day, we're looking for about 400 trees a hectare. So you can do it an 8 by 8 meter lattice, or you can do it in like a 12 meter by 3 meter. So you can actually mow between them and get a grass until the trees are strong enough to allow in. And the last thing we've been doing, we've bought some really interesting gourds in from Spain called cactus gourds, which seem to be really very resilient, not only to cattle, in our case, red deer. Right. Because we have whatever about cattle, You get our stags at those, they will just go through anything. And our cactus guards have stood up to our red deer stags. So we're quite taken by this.
John, sadly, we're going to have to leave it there.
Could I just ask one question, just to finish up? It's not a question. It's not a question. It's just that there is a lot of kind of technical information about just technical issues in terms of the research that's going on. Is there a website that people can go to actually see what's going on at Dowd and some of the research that's there?
We haven't necessarily got all our act together.
Right.
What we would encourage is actually, once we get out of COVID, is, we have open days, and also if there's organized structured groups, we take visits. I mean, the year before COVID, we had over 50 structured discussion group visits came to see us. We also have open heritage days. So, and so we are very keen not only to have farm visits, but lay people, genuine people who want to come and learn more and want to see more about the heritage too. We normally would open for Heritage Week or parts of Heritage Week. We try to cater for all spectrums of interest, because actually we believe that public engagement is fundamental and something our industry are not good at. And we hope through the asset we have, the platform we have, we can step into that place and hopefully start to bridge the gap and bring diverse views closer together. Because we all have to live on this island together. We need a healthy life, and we need a healthy environment, and we need profitable farmers.
Thank you very much, John, and Pat. Thank you for helping with the questions today. Always a breath of fresh air, John, and we really appreciate your wonderful breadth of knowledge and experience with the agri-food sector. So really appreciate your time today. And as you know, Teagasc is currently developing a network of signpost farms, which will be sharing details about that in the new year. We've recently appointed Dr. Tom O'Dwyer as the head of the Signpost Farm Programme. So we hope to have Tom early in the new year to talk about this network of farms where we're actually putting into practice what we're talking about today, and also acting as that demonstration area for farmers to come and see. So hopefully there'll be opportunities to work together on that in the future. So I just wanted to share with everybody that next week we'll be launching Hedgerow Week, and we'll be joined by Minister Pippa Hackett and also Dr. Catherine Keena, who's going to talk about growing hedgerows for a sustainable future. And we look forward to speaking with Catherine and Minister Hackett during our session next Friday. Also to remind you that you can get a copy of our presentation from today and the recording of the webinar on our YouTube channel. And finally, I want to thank our production team, Yvonne Maher, Andy Boland, and Pat Murphy, and also our partners, the National Rural Network, Dairy Sustainability Ireland, and Food Ireland SkillNet, in joining us on this venture.